When working with trigonometry, I want you to be able to understand where it comes from. So the first thing we're going to do is look at this trigonometric table over here. So this table, the way you read it is you look at the very left and you'll be able to see the degrees of the different angles that you might be dealing with. And it starts at 0 and it goes all the way down on the first page to 45 degrees, and then on the second page the angles go all the way down to 90 degrees, which is pretty impossible, right? Because that means you would have a triangle with two 90-degree angles. So keep in mind this is always for right triangles. Trigonometry is always for right triangles. So what we know is that all right triangles are going to, if the sides have the same ratios as another right triangle, then they give us the same trig ratios. So what I mean by that is if we go down to the 45-degree angle down here, what it tells us is that any triangle that has any right triangle that has a 45-degree angle. So let's say, for example, that we have a 45-degree angle right here. Any triangle that has a 45-degree angle is going to have all of these ratios that we see when we look in this table. So right here's sine, this is cosine, and this is tangent. So what that tells us is that for any triangle with a 45-degree angle, the sine of the 45-degree angle, that particular angle, which is opposite over hypotenuse, is always going to divide, the ratio will divide to give us the decimal 0.7071. It tells us that the cosine of that angle at 45 degrees, which is going to be adjacent over hypotenuse, will also give us 0.7071. And the tangent of that 45-degree angle, which is going to be opposite over adjacent, will always divide to give us a ratio of 1. So that's what this highlighted in blue tells us, okay, this table. And all it is a table that has figured out that for every 45 degree right triangle, these ratios will hold true. Now the reason I said 45 degrees is because if one angle in a right triangle is 45, the other one has to be 45 in order for the angles to add up to 180. So I know that this is actually an isosceles triangle, and that's why we see the ratios with sine and cosine being the same, because our two legs are going to be congruent in this particular case. So it's kind of a special triangle. Now let's say, for example, that this was a 45 90-degree triangle, which we now know is an isosceles triangle. Since the two angles are congruent, then the two legs will have to be congruent. So since we know it's isosceles, if one side is 8, one leg is 8, the other leg is 8. So let's solve and see what the hypotenuse would be. Give that a try using the Pythagorean theorem. So I have solved for the hypotenuse and found it to be 11.3 if I have a 45 degree triangle whose two congruent sides are 8. So since the hypotenuse is 11.3, let's find the tangent. Since we know that, let's find the tangent of our 45 degree angle, and we're dealing with the one in red. Although it doesn't really matter, right? That's why cosine and sine are the same. You can see it won't matter because adjacent is 8 and opposite is 8 for our angle down at the bottom. But if we use the angle up at the top, then our opposite is 8 and our adjacent is 8. So it works out the same. But anyway, for tangent of the 45 degree angle down here at the bottom left, the tangent is going to be opposite over adjacent, which is going to give us 8 over 8, which gives us 1. And that's what we expected from our table. We expected to get 1 for tangent right here. So now, and that's how we set it up. Now let's try for sine and cosine. So now let's find sine of 45 degrees, and we're going to use that bottom angle. So sine is opposite over hypotenuse. The opposite is 8, over the hypotenuse, which is 11.3. Now, you probably, like I did, had to round to the tenths, or you had to round to the tenths to get the hypotenuse. So keep in mind our ratio will not be perfect because of the rounding. So what I'd like us to do is divide this out. So use your calculator and divide 8 by 11.3. Notice when you do, you get 0.707964, etc. And we're going to go ahead and round this to 0.708. Notice that 0.708 is very, very close to the sign 0.7071. And the reason it's not exact is because we had to round when we did the Pythagorean theorem. Otherwise, it would have come out exact. So you can see how with any 45-45 90-degree triangle, when you find the ratio of opposite over adjacent, which is the tangent, you'll get a ratio that simplifies to 1. If you find the sine of the 45 degrees, which is the opposite over the hypotenuse, you will get 0.7071 if you did not have to round when finding the hypotenuse. So you can see how that actually holds true. So there are these tables that have already calculated all of these ratios simplified into decimals. So each of these decimal is just a ratio that's been divided out, a fraction that's been divided out for us. Now notice very few of them are real simple ratios like 1 when we found the tangent of 45 degrees and we ended up with 1. Most of them are long decimals that have been rounded. So now we're going to apply this information and understanding of the ratio tables, the fact that when you find a triangle that has, say, for example, a 36-degree angle, we know that every triangle that's a right triangle and has a 36-degree angle will have a ratio for the sine that equals 0.5878, a cosine ratio that will equal 0.8090, and a tangent ratio that will equal 0.7265 for any right triangle that has one angle that's 36 degrees. That will always hold true. The numbers will always divide to equal these ratios. So now let's look at some word problems with trigonometric ratios and applying trigonometry. So in this example, I have a rocket that has soared into the air. The distance from where I launched my rocket, so here's where I launched it, where I'm standing, and where the rocket landed, this is where it lands, is 35 feet. The angle at which the rocket blasted off into the air was 45 degrees. So that's the angle I'm looking up at the rocket from. It's called an angle of elevation. How high did my rocket fly? So how high it flew is right here. It's the distance from its highest point to where it would naturally just drop straight down. So think about the rocket is going to take off in flight at an angle and get higher and higher and higher. And then when it gets to its highest point, it's going to fall straight down and land on the ground. And of course, this is approximate. And then you can find the distance from where you sent the rocket off to where it actually landed by measuring from where you are to where the rocket lands. Okay, so this is how we would set up this problem. The first thing I'm going to do is write down 45 degrees to help me stay straight which angle I'm working with. Okay, now I'm going to look at my 45-degree angle and look at the two sides I'm dealing with to figure out which trig function I'm going to use, sine, cosine, or tangent. So they're called trig functions. Sine, cosine, and tangent are called trig functions. So, or trigonometric functions. I see that I have my side opposite as x, so I'm working with a side opposite. And then I have a side that's adjacent right down here on the bottom. So if I'm working with opposite and adjacent, what do you think we would use for our trig function? If you think tangent, you're correct. So it's going to be tangent of 45 degrees equals opposite over adjacent. And we're going to fill that in with the numbers in this problem. So the tangent of 45 degrees equals x is opposite of the 45 degrees, and then 35 is adjacent to the 45 degrees. Okay, so now we figured out to use tangent because we're referring to the angle that's 45 degrees, and that's the angle that helps me figure out the relationship of these sides, right? So x is opposite because of where the 45 degrees is and where the x is. And 35 is adjacent because of where the 45 degrees is and where that side is. So now we want to solve for x. So the way we're going to solve for x is we're going to multiply by 35 on this side, on the right, because multiplying is the inverse of dividing. So those will cancel to equal 1. And if we do that to the right side, we have to also multiply by 35 on the left side in order for our equation to stay equal or balanced. So when we simplify here, we end up with x equals 35 times the tangent of 45 degrees. So let's think about what that means. We saw earlier the tangent of 45 degrees is actually 1. We saw that right here. The tangent of 45 degrees is 1. You can look up here and see tangent. This is the tangent column. So we know that this actually means 35 times 1. The tangent of 45 degrees is just a ratio that's simplified to a decimal, the decimal of 1. All right, but we're not always going to know that. So we're going to use our calculator, and the calculator is going to look up what the tangent of 45 degrees is. So what we'll do is put this straight into our calculator. So when you have your calculator, and different calculators will be different, we're going to find the tangent, first of all, of 45 degrees. So I'm going to put tangent 45. So I had to type tangent and then hit 45, and it gave me 1. Okay, now I'm going to put times 35 into my calculator, and it equals 35, of course. So x equals 35. And it's feet because we're looking for how high our rocket flew. Okay, so to sum up, what you do is you use your algebra. So you set up your trig function, tan of 45 degrees, set it equal to opposite over adjacent, and put in the two sides, the side that's opposite over the side that's adjacent. Then we use algebra to solve. So we're trying to get our x by itself, and we find that x equals 35 times the tangent of 45 degrees. And you put that straight into your calculator. Different calculators will do it differently. And you get x equals 35 feet. So on your calculator, you're going to hit the second button and then the pi button, which has trig right above it. So the second button makes all these gray words become the buttons. So when you hit second and pi, it's actually activating trig. And then when you go into that, you will arrow down. So arrow down until you see tangent. That will be your third option. And then hit enter. And then you're going to have tan with the parentheses show up, and you're going to type 45 and then put your closed parenthesis. And when you hit enter, it'll tell you the answer is 1. So that's how you find the tangent of 45 degrees. If you want to do 35 times the tangent of 45 degrees, you can go to tangent 45 just like we did. And after you see that on your screen, just type in times 35 and hit enter, and that should give you 35. So that's how you use your trig keys. Let's look at another problem. Here Sandra spotted an owl 18 feet in the air from the ground. The angle between Sandra and the ground as she is looking up at the owl is 30 degrees. How far is Sandra from the owl? Try to draw that. So this is what your picture should look like. Hopefully yours is a little better than mine. Anyway, so we need to write down our degree that we're working with, which is 30 degrees, and then think about what the relationship is with the sides. So for example, we know that x is the hypotenuse, obviously. So what about 15? Is that going to be opposite or adjacent from 30 degrees? Well, that's opposite, right? So since we're dealing with opposite and hypotenuse, what would that be? If you said sine, you are correct, because that's opposite over hypotenuse. So the sine of 30 degrees in this case is going to be 15 over x. So now we need to solve for x. Well, we can't have x in the denominator, so what we're going to do is multiply it in the numerator, because multiplying and dividing cancel each other to equal 1, and that will get x from being in the denominator. And if we do that to the right side, we have to do it to the left side as well. So we're going to end up with x times sine of 30 degrees equals 15. We need to continue solving for x. So remember, sine of 30 degrees is just a decimal, right? So we're going to divide both sides by sine of 30 degrees. And that's the same thing as dividing by a decimal. You just don't know what the decimal is. Just so you know, sine of 30 degrees is 0.5, but you wouldn't know that off the top of your head. So this is basically like doing the following equation. X times 0.5 equals 15, or 0.5x equals 15, where you divide both sides by 0.5 to solve for x. So that's basically what we're doing. You just don't know that the sine of 30 degrees is 0.5, so you divide both sides by sine of 30 degrees. So x is going to equal 15 divided by the sine of 30 degrees, and when you put that into your calculator is going to figure out, it's going to substitute 0.5 in the place of sine of 30 degrees, but you don't ever see that happen. I just want you to understand what's happening. So go ahead and put that into your calculator and see what you get. And you should get 30 feet. So the distance from Sandra to the owl is 30 feet. Let's look at the next problem. Try setting up the triangle for this problem. This is what your triangle should look like. So we're working with solving the degrees, which is different than what we've been doing. We've been so far solving for a side, and we knew one side in the degree. So here we're going to write down x degrees to be thinking about what angle we're working with. And let's think about it. Is 10 feet going to be opposite, adjacent, or hypotenuse? It's going to be opposite, right? And from the x degree angle. And is 20 feet opposite, adjacent, or hypotenuse to the x degree angle? It's adjacent, right? We're not dealing with the hypotenuse at all. Therefore, this is going to be working with tangent. So the tangent of x degrees is going to be opposite over adjacent. So the tangent of x degrees is going to be 10 over 20. So when you're solving for the degree instead of the side, you're doing an inverse operation, just like squaring and square rooting are inverse operations, multiplication and division are inverse operations. Well, finding a side versus, or finding the ratio of sides is an inverse to finding the degree measure when you're working with trigonometry. So the way you write the inverse is you use a -1 exponent. So I'm going to write tangent and put a -1 exponent, and in parentheses I'm going to put the ratio. So what this is telling me is that I'm doing the inverse operation of finding the ratio. I'm actually solving for the degree measure, and this is the notation you use. So both of these mean the same thing. The second one is what you put into your calculator. So now when you go to your calculator, you're going to arrow down 6 times until you see tan to the -1. So in your calculator, you arrow down until you highlight tan to the -1, and you hit enter. And then on your calculator, you'll see tan to the -1 with a parenthesis. Type in 10/20 using your fraction bar and hit enter, and that will give you your degree measure. Rounded to the tenths, you should get 26.6. And remember, this is degrees, so we actually just found the degree measure of our angle. Let's move on to the next problem. Go ahead and draw the picture for this one. This is my picture. So 35 degrees is the angle that we're dealing with. Let's look at that angle. 35 feet, is that going to be opposite, adjacent, or hypotenuse to the 35 degree angle? It's opposite. And then x feet, is that going to be opposite, adjacent, or hypotenuse to the 35 degree angle? It's adjacent. Also, we're not dealing with the hypotenuse at all, so this is going to be tangent. So tangent of 35 degrees is going to be opposite over adjacent. So tangent of 35 degrees is going to be opposite is 35, adjacent is x. So go back and try this one based on the previous problems that we have done. Give that a try and check back. Rounded to the nearest tenth, you should have 50 feet. All right, let's look at the next problem. Take a minute and set this one up as a triangle and check back and see if you have it set up correctly with the picture. Here's the picture to help you get it set up. Now try this problem and check back and see if you did it correctly. Keep in mind you're solving for the angle here, so you will use your inverse function, whichever function you decide to use, sine, cosine, or tangent. You should end up getting 53.1 degrees. Check your steps and see if they look good. And let's move on to the next one when you're ready. Try to set this triangle up and check back. This is what your picture should look like. So now try to solve it. And you should get 26.4 feet.